Hi YouTube, Timothy Unkert here. In this video, we're going to talk about the distributive property. So the distributive property generalizes the distributive law. And the distributive law says that a quantity times a group of quantities is the same as that quantity times each of the individual quantities in the group. So an example of this would be, AB plus AC is the same as A times B plus C, or we could write it the other way around. A times B plus C is the same as AB plus AC. So to see this in action, let's look at a few examples. Okay, let's look at example 1 here of the distributive property. We have 4 times the quantity 5 plus 3. Now, if I were to do this the traditional route using PEMDAS, so PEMDAS is a way of figuring out your order of operations. Also, sometimes you might hear, please excuse my dear Aunt Sally is another acronym. And PEMDAS stands for parentheses, exponents, multiplication and division, which are treated equally from left to right, and addition and subtraction, which are treated equally left to right. So if we're going to do this via the PEMDAS method, I'd have 4 times 5 plus 3. Well, what would I do first? I would do the 5 plus 3. So 4 times, 5 plus 3 is 8, so 4 times 8. And then 4 times 8 is 32. So we get 32 doing it the PEMDAS method. If I want to do it via the distributive property, remember we have A times the quantity B plus C is the same as A times B plus A times C. So it'd be 4 times the quantity 5 plus 3 is the same as 4 times 5 plus 4 times 3. Okay, so 4 times 5 is 20. And 4 times 3 is 12. And 20 plus 12 is 32. So you see whether we do it the PEMDAS method or the distributive property method, we're going to get the same result. Okay, let's take a look at a few more examples. All right, in example 2, using the distributive property, we have 2 times the quantity x plus 3. Now you should note that if we're going to simplify an expression like this, we really couldn't use PEMDAS because we don't know the value of x. We can, however, simplify it using the distributive property. So what we can do is we can take 2 and multiply it by x, and then 2 and multiply it by 3. And when we do that, we get 2 times x, which is 2x, plus 2 times 3, which is going to be 6. Okay, so we've simplified this now to 2x plus 6. So this is where the distributive property starts to shine. Let's continue looking at how the distributive property can help us simplify expressions in the next example. Okay, in our next example of the distributive property, we have x times x minus 7. And let's say we had a problem where we wanted to simplify this expression. Well, we'll use the distributive property. We'll do x times x. That's going to give us x squared. Anything times itself is itself squared. And then we'll do x times this minus 7. This is like plus negative 7. So I could write this as plus negative 7. So x times negative 7 is negative 7x, or we just have minus 7x here. And there we go. We've simplified that one. Let's get to a couple more complicated examples after this. Okay, in this example, we have x times a trinomial. And right now, this trinomial is semi-factored. We could factor it further, actually, but let's say we wanted to expand it out by using the distributive property. We can do that with a trinomial as well. So what we can do is we just multiply x times each term, so x times x squared. Keep in mind that this is like x to the first power. So when we multiply two exponents with the same base, so these both have the base x, we add the exponents. So this is going to be x cubed. And then, again, this is like a 1 here. So we're going to do x times minus 2x, so x to the first times minus 2x to the first, that's going to give us a minus 2x squared. And then we're going to do x times 1. That's just going to be 1x or just plus x. We don't even have to write the 1. It's understood that the coefficient in front of x is 1 if we don't write it. And that would be finishing up this example. In our next example, I'm going to do one more example, and I'm going to do double distribution in our last example. I don't want to delve into that too much. I'll probably make a separate video on that, but I think you should see the process. Okay, in this example of the distributive property, we're looking at double distribution. So we're doing a binomial times a trinomial. So we have the quantity x minus 2 times the quantity x cubed minus 4x plus 1. Before we do this out, I just want to make a reminder that this is like x to the first power, this is like x to the first power. And how we want to work this out is we want to break apart this first binomial. So I'm going to break this apart into x times x cubed. Again, this is x to the first minus 4x to the first plus 1. And then I'm going to do a plus. So this is like plus negative 2 here. I could rewrite this as plus negative 2. So plus negative 2 times x cubed minus 4x to the first plus 1. Okay, so what we're essentially doing here is we're taking each of these terms and multiplying it by each of these terms. So I'm taking the x, I'm multiplying it by every term here. I'm taking this negative 2 and I'm multiplying it by every term there. So now let's work this out. So we have x to the first times x cubed. Well, remember, same base. We're going to add the exponent, so 1 plus 3 is 4. So x to the fourth. Okay, then x to the first times a minus 4x to the first. So that's going to give me a minus 4x squared, because 1 plus 1 is 2, obviously. Okay. All right, next we're going to do x to the first times 1, which is just 1x, and we can just write plus x. Okay, plus, now we're going to do negative 2 times x cubed. We're going to get negative 2 x cubed. Then we're going to do negative 2 times negative 4x to the first. That's going to give me a positive 8x to the first, which I can just write as positive 8x. And then we're going to do a negative 2 times 1, which is just negative 2. Now, to really simplify this out, we want to combine our like terms. So we want to take a look and see, well, what do we have like each other that we can combine? So if I look at x to the fourth here, I'm looking all the way across. I have nothing like x to the fourth. So I'm just going to go down here and write x to the fourth. And what I'm going to do is, as I combine these, I'm going to cross them off. So I know that I'm done with combining them. And that's something that a college professor taught me that just helps you keep track as you combine terms. Because as you get more and more complicated, you're going to have a bunch of terms and you want to keep track. So I'm going to cross off the x to the fourth. The next thing, I'm actually going to skip the x squared. I'm going to look for the next highest power, which is negative 2x cubed here. And so what I want to do here is I want to go from fourth to negative 2x cubed, x squared, and so on. So I look for anything else that has x cubed. There's nothing, so I'm going to bring it down, negative 2x cubed. And I'm going to cross that one off. Next, I'm looking at x squared, and I look across, there's nothing like negative 4x squared, so I'm going to bring that down, negative 4x squared. And cross that one off. Now I'm to x to the first, or we just say x. So I have x here, that's 1x. This is like 1, even though there's not a 1 always written there. So 1x plus 8x, that's going to give me a positive 9x. And I'm going to cross both of those off. And then my last term that I have to bring down is the minus 2. Bring that down. Cross it off. I see I have everything crossed off up here. So that's as far as I can go. So this is my expanded form of this one that's simplified out. If you like this video, please give it a like and subscribe if you haven't done so already. And thank you for watching. See you in the next one.